Okay, this is the first problem. Sand is pouring at the rate 12 centimeters per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always one-sixth of the radius of the base. How fast the height of sand cone increasing when the height is 4 centimeters? It is a simple problem. We are solving some simple problems. And volume of a cone is one third pi r square h. This is important formula for you, which we should use. Uh, Therefore, now r is equal to r and h. They have given some relationship. Therefore, volume is equal to one third pi 6h bracket square into h, which is equal to 12 pi h cube. Okay. So change in volume per second dv by dt equal to 12 pi into 3h square dh by dt. If you solve this for h is equal to 4, we have dh by dt is equal to 1 upon 48 pi, something like that. Next problem, a particle moves along 6y is equal to x cube plus 2. Find the point on the curve. At which y coordinate is changing 8 times as fast as the x coordinate. Let me not solve this. This is easy. So let me write down only answers. Answers. The x coordinate of first point is +4, y coordinate is 11, and second point -4, and y coordinate is -31/3. Okay. Question 3. If the curve ax square plus by square is equal to 1 and a dash x square plus b dash y square is equal to 1 intersect each other orthogonally, then prove that. Okay, this is also another easy problem. Solve it. These are different flavor problems, therefore I am taking. Theory is exactly same. First of all, they intersect each other. Let x1, y1 be the point. Let x1, y1 be point of intersection. Okay. So what will happen is x1, y1 will satisfy the first equation, x1, y1 will satisfy the second. Therefore, we will get some relationship between them. A minus a dash times x1 square is equal to minus of b minus b dash times y1 square. Makes it a minus a dash upon b minus b dash is equal to minus y1 square upon x1 square. So this is the first relationship that you have. Another information which is given is they intersect each other orthogonally. So the slopes of tangents at the point of intersection they are perpendicular. Product of the slopes is -1. So we have to differentiate. So 2ax plus 2by divided by dx is equal to 0. Correct? This implies dy by dx is equal to minus 2ax upon 2by. So at x1, y1, the slope, so dy by dx, this is general slope of any point x comma y on that curve. So we want dy by dx at x1, y1, it will be minus ax1 upon b y1. Similarly, we will have dy by dx on the other curve x1, y1, it will be a minus a dash x1 upon b dash y. Is that right? So these two slopes, product of them is equal to -1. So this implies minus a by b x1 y1 upon y1 into minus a dash upon b dash to x1 y1 is equal to -1. So what do you have as a relationship? Minus y1 square upon x1 square is equal to a dash upon b dash. That's it. That's the end of the story. This is second. Equating this and this, you get desired relationship. 1 and 2. Good. Next. ABCD is a rectangle in which AB is equal to small a and AD is equal to small b. Determine the dimensions of the rectangle of maximum area. Determine the dimensions of the rectangle of maximum area whose sides pass through the vertices of rectangle A, B, C, D. Okay, what do we mean by this? You have some rectangle ABCD with you. Right. Now you are supposed to draw another rectangle such that the sides will pass through the vertices of ABCD. Maybe you can call it as PQRS. Hmm. Okay, so let me just discuss. I mean, in this case, you can consider this angle to be theta. That is one way of parameterizing and finding the value. This is small a, this is small b. Therefore, by symmetry, we will be able to find out the area. Let me quickly write down PQ is equal to A cos theta plus B sin theta. QR is equal to A sin theta plus B cos theta. Therefore, area of rectangle PQRS is equal to product of these two. A cos theta plus B sin theta into A sin theta plus B cos theta. Okay, you can consider this as y, and then you can simplify it a little bit. And maybe you can take dy by dx. dy by d theta is equal to, if you do it meticulously properly, then you will end up getting dy by d theta is equal to a square plus b square times cos 2 theta. If you equate it to 0, A is not, this bracket is not 0, therefore this has to be 0, and the angle theta is between 0 to pi by 2. Okay, therefore 2 theta is 90, therefore theta is equal to 45. This will give you theta is equal to pi by 4. Now at pi by 4 you need to cross check whether d2i by d theta square is less than 0 or not. If it is less than 0, which is, this will give you maximum area. This will give you theta at pi by 4 area maximum.
सर
हाँ
सर ते कॅल्क्युलेशन्स कमी करण्याची एक मेथड आहे
हाँ
डी यू बाय डी थिटाचे. जर आपण एरियाला लिहिताना असं लिहिलं की ए साइन थिटा इंटू ए कॉस थिटा प्लस बी साइन थिटा इंटू बी कॉस थिटा, म्हणजे बेसिकली ते 4 ट्रायंगल्सचे एरिया ऍड करायचे प्लस ए बी, तर मग ते डिफरन्शिएट करायला सोपं पडतं.
चालेल, सेमच आहे सगळं, बरोबर आहे. चालेल चालेल चालेल. Therefore maximum area PQRS is equal to a plus b bracket square upon, that is the answer. Okay, last problem in this series, question 5. A box with square base is to have an open top. The area of the material for making the box is 192 centimeters square. What should be its dimensions? In order that the volume is as large as possible. Got it. Okay, let us finish this. Let the base has side x and height y. ठीक है, फटाफट करून टाकतो. Therefore total surface area x square plus 4xy is equal to 192. This gives us y is equal to 192 minus x square upon 4x. Volume V is equal to x square into 192 minus x square upon 4x which is equal to, when you simplify this, then find out dv by dx equated to 0 gives you x is equal to plus or minus 8. Of course, minus 8 is not acceptable. You can cross check d2 v by dx square. It is less than 0. Therefore, this volume is maximum at x is equal to 8. And y comes out to be equal to, so dimension of the box is 8 by 4. Okay, so that completes one part, application. You can solve as many problems as you want on applications of derivatives. Moreover, in every problem, the same principles, whatever we have discussed, are going to be used. The most difficult part in the application of derivatives is a word problem to be converted into a mathematical problem. Once you get that correct, essentially it has to be a one variable problem, and we have studied the method by which we can maximize or minimize one variable problem. So that is how you are supposed to go about it. Okay, now let us move on to further remaining theory part. Suppose I tell you, suppose I give you a curve and I want you to find the function which, if we sketch, will give that curve. Say for example, let us take the simple one. This is a circle with center at origin and radius equal to a. Okay, so given curve, find function. Type of question I am asking you. When I ask you find function, what are you supposed to find? Three things. One, domain. Second, codomain. And third, formula. Rule. Formula. So now I am giving you a curve. Can you give me the function? F. Value. First thing that we need to understand is the geometry that we have drawn right now is a circle, and is as such cannot be expressed by using one formula or one rule, because if we can do that, then it is not following the definition of function. For same x value, you have two y values, so it fails as far as definition of function is concerned. So we cannot have a one rule which will define this particular curve, and hence you need to have more than one rules. So what we can do is we can define f1 from say minus a to a such that going to r, or you can take them from say 0 to a, or you can take it r. Codomain, if it is bigger, it doesn't matter, but minimum it has to be there. At least it should be equal to range. That is the condition of codomain. And then f1 is equal to plus radical f1 of x is equal to plus radical a square minus x square. This will give you this part of the curve. including 0. If x is equal to 0, if x is equal to minus a or plus a, you will get 0. So including this. And you need to define f2 from maybe same domain to codomain 0, minus a. f2 of x is equal to opposite of radical a square minus x. Is that correct? Good. Now, how about continuity of this function? Continuity of this function over this domain, we will say continuous. Yes. What about continuity of this function over that domain? Yes. Why? Why do we say that it is a continuous function over that domain? Because of the simple reason that the function is this function. If you observe, say for example f1 is a square minus x square raised to 1/2. So it is composition of polynomial. First inside bracket is polynomial followed by nth root function, where n is equal to 2 in this case. So nth root function on that domain is continuous and polynomial function on that domain is also continuous. Therefore, the given f1 is continuous. नहीं तो नंबर independent. Okay, so continuous. Is this the only way to define this curve, which is circle, or can we have some more definitions? Already few students have done it. So can we try few more definitions? Or is this, in how many ways actually we can define this curve in terms of function? In how many ways we can define this curve in terms of function? So practically, if you keep on changing the domain, you can consider it as a separate function and you can do it. So infinitely many ways of defining this curve as a function. You can split these domains into parts and define it. That is not the problem. So practically there are infinitely many ways of defining this circle as a function. So we said that it is continuous. f1 is continuous because it's a polynomial followed by nth root function. Both of them are continuous. Therefore, f2 is also continuous. Lower half of the circle is also continuous. Upper half of the circle is also continuous. What do you think about differentiability of this function? What do you think about differential? Continuity, yes. What about differentiability? Bola, what do you think? Are they differentiable? So this function, whatever we have defined, f1 and f2 are differentiable everywhere except minus a and plus a, because Here the tangent is going to be vertical, so the limit exists but is not finite. So differentiable everywhere except at x is equal to minus a comma a. Correct? Okay. Now suppose I give you a curve. I will change the curve little bit and ask you to give me a function. Say for example the curve is like this now. Of course it is a quarter of a circle. This is same. I mean a comma 0 minus a comma 0 0 comma a 0 comma minus a. How will you define this function? Let me write down the obvious definition of this. F of x is equal to opposite of radical a square minus x square if minus a is less than or equal to x is strictly less than 0 is equal to plus a square minus x square if 0 less than or equal to x less than or equal to a. Okay? That is what is the definition of this function. Now find f dash of x. In this case, algebraic formula पाहिजे मला. What is f dash of x for this function? What is the derivative of the first part? Can you tell me?
X by root a square minus x square.
Huh?
X by root a square minus x square.
X upon root a square minus x square if minus a less than equal to x less than equal to 0 and is equal to minus x. Is it correct?
Yes, sir.
0 is so basically
तर तिकडे स्ट्रिक्ट इनइक्वालिटी पाहिजे ना.
huh?
Sir.
Okay.
X strictly bigger than minus a and x strictly less than less a.
Ah,
Also
correct.
strictly greater than 0.
Because otherwise we will fail. आता बरोबर आहे? आता बरोबर आहे का?
तर झिरोला पण पाहिजे.
झिरोला का पाहिजे? एवढ्या
कंटिन्युअस नाही आहे.
हा?
कंटिन्युअस नाही आहे ना झिरोला.
झिरोला काय कंटिन्युअस नाही आहे. x is equal to 0 ला व्यवस्थित डिफाइंड आहे की x is equal to 0 ला इथे 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 डोमेन मध्ये नाहीच आहे. हा डेफिनेशन नाहीच आहे. हीच डेफिनेशन आहे. x is equal to 0 ला. 0 ला काय प्रॉब्लेम नाही. ऍब्सोल्युट
पण झिरोला डेरिव्हेटिव्ह एक्झिस्ट नाही करत.
काय?
Sir, the derivatives on both sides are equal, but the function is not continuous. So we can't say that it's differentiable at 0.
That is what you want to say. That function is not continuous at 0. Therefore, derivative is not doable. In fact, both the tangents have slope equal. Correct. Derivative value is 0. Dy by dx at 0 is 0. Here you can draw tangent. Na? Rest of it. Okay. So now what I want to, okay, whatever you are saying is correct. Okay, let us accept that it's not continuous. So there is no question of differentiability at x is equal to 0 as far as this function is concerned. But what I want to bring it to your notice is, suppose we directly take this x square plus y square is equal to a square, and we start differentiating. That is what we have been doing, but this is what I am discussion which I am making right now is making it little legal. Differentiate this, whatever we call it, as implicitly defined implicit function. Actually, it's a curve. It's an equation of a curve which we will consider as a implicit definition of a function, and we want to find out slope of tangent at any point on this curve. What we do is we just differentiate 2x plus 2y dy by dx is equal to 0. We get dy by dx is equal to minus x upon y. Is this also minus x upon y? Is this also minus x upon y? That is what I want to check with you. This is how you have defined your function. So I can replace this by y. So this lower part is minus x upon y. Yes. And this is y. So radical a square minus x square is opposite of y. So I can replace this here by opposite of y, and therefore both of them are actually x upon opposite of y, and this is opposite of x upon y. So practically it is opposite of x upon y. So what I want to bring it to your notice is, you need not have to keep playing with these functions for explicit definition. Understand this. Explicit, this is explicit. Y is function of x and y is separate from x. Okay, so sometimes you are able to do this separation, sometimes algebraically this separation might not be possible. In that case, we will have to do away with implicit type of definition of the function. And then what we find is, if we follow this mechanism of finding out dy by dx, so wherever it is, I mean, not necessary. If we write a big polynomial mixture, maybe pair of lines or something like that. So relation, I mean, we can call it as relation of f of x comma y is equal to, say, x cube plus 2x square y minus 3x y fourth plus x square y square minus 3, something like this. And we want the slope of tangent at any point on this curve. We do not know what this curve is, we have not studied it. But then, yes, I mean, whatever discussion which we are doing right now, we can break, if we could sketch this function, we can break it into parts, we can create parts of domain and define it like this. This part is with this definition, this part is with this definition, something like this. And we can really convert it into explicit definition, provided algebra allows us to do that. If algebra is not allowing you to get y in terms of x, then explicit definition may not be possible every time. But this is a curve, maybe this is something like this in xy plane, and you want what is the, suppose we could find out some point on this curve. Suppose I remove this 3, suppose I remove this 3 from this, then 0 comma 0 I think satisfies this, is equal to 0. Suppose this is f of xy is equal to 0, x comma y 0 comma 0 satisfies this. So 0 comma 0 is going to be there on this curve, and I want to know what is the slope of tangent at 0 comma 0. In that case, you can directly start doing this. 3x square plus 2x square dy by dx plus 4yx minus 3 bar 12 xy cube divided by dx. Are you there? समजते काय चाललंय ते? त्याच्यानंतर minus 3y4 plus 2x square y divided by dx plus काय येणार आहे 2x square y म्हणजे ह्याला डिफरन्शिएट केला आता 2y square x is equal to 0. And now you collect this dy by dx on one side and put everything else as function of x comma y on the other side. That is what is your derivative. And if you want to find out what is the slope of tangent at say x1 y1, you substitute x1 y1 in this formula, you get a slope. That is what is implicit definition of a function and implicit differentiation. Okay, I think I have made some point here on the screen. You write down everything and then we okay. So this was about implicit differentiation. Now, so there is something called parametric differentiation. Let us check what is the theory behind that. We said x is equal to f of t and y is equal to f of t, some other function. Both are defined, y is defined in terms of t and x is defined in terms of t. Then, or maybe you can use another letter for y. We say dy by dx is equal to dy by dt divided by dx by dt. That is what is in use. And practically, if we consider these as ratios, it will be true, but they are not ratios, they are operators. But then finally the result comes true. So if we define now, okay, what is the parametric equation of the same circle? X square plus y square is equal to a square. X is equal to a cos theta and y is equal to a sin theta. This is what is parametric. So x is defined in terms of theta, y is defined in terms of theta, and now we want to find out dy by dx. Let us check with this. What is dx by d theta? Dx by d theta is equal to a minus a sin theta. Correct? And what is dy by d theta? Is equal to a cos theta. Therefore, dy by dx in case of parametric differentiation is a cos theta upon minus a sin theta, which is equal to minus cot theta. Oh, minus cot theta. And what is theta in this case? This is the angle theta, and you are talking about this point. X is a cos theta. That means you are talking about a cos theta. This is the angle theta I am talking about, and y coordinate is a sin theta, right? So what is cot theta? What is cot theta? Cot theta is y by cot theta is tan theta is y by x, therefore cot theta is x by y. So minus x upon y. Oh, it is same as this. Do you see that there is a synergy between all kinds of differentiation that we are trying to do? So it is okay, but then how do we say that this is fine? How do we say that this is okay? And therefore, Let us do a theorem by which we legalize parametric differentiation. And the theorem is as follows. Let f be defined from I to R. Let g be defined from I to R. Notation. X is equal to f of t. And y is equal to g of t. Okay. If f dash exists, and is continuous on I, this is condition 1. Condition 2, if g dash exists and is continuous on I. Condition number 3, f dash of t is not equal to 0 for every t belonging to I, then for f is strictly increasing, or strictly decreasing on I, that is first part of story. And if it is strictly increasing and strictly decreasing, then inverse is possible. But then सॉरी एकच मिनिट जरा मी घोळ मारतोय काहीतरी लिहिताना. लक्ष नाही. वेट, आणि माझं पण चालू नाही आज व्हाईट बोर्ड. सॉरी. We are writing proof. Then for simple dy by dx is equal to dy by dt upon dx by dt.
So the f dash of t not equal to 0 काय लागेल?
डिनॉमिनेटर मध्ये टाकलंय ना याला. f dash of t not equal to 0, कारण इथे डिनॉमिनेटर मध्ये लिहिलंय, तिथे डिनॉमिनेटर मध्ये 0 नको यायला, नाहीतर आपलं डेरिव्हेटिव्ह फायनाइट होणार नाही म्हणून. So this is the theorem which will allow us this parametric differentiation. So a few minutes later I will write down the proof. Okay, let us see what we can do. F dash exists and it's continuous. G dash exists and it's continuous. The meaning of these two statements is that basically f dash and g dash exists and continuous. That means f and g are either strictly increasing or strictly decreasing functions in the desired domain. Okay, so let me just make the skeleton of the proof ready and we will discuss this. Now basically what we want to do is x is a function from, let me check g. G is from a comma b to e comma f. Let us call this function g, and from a comma b to c comma d. Let us call this function in this direction f. Okay, so f, this is our t. T belongs to this domain. So this is what is our t. So f of t is your x. So c comma d, x belongs to c comma d. T belongs to a comma b. So f of t is x and g of t is y. Okay. So therefore it is important to establish the relationship between x and y. That is what is our skeleton. Okay, and hence now if you see the arrows, from this we are going towards x, from this we are going towards y, and now we want to express dy by dx where y is a function of x. That is what is the form, that is our explicit definition of a function. So we want x to be going to y, so it is going to be a composition, and if it is going to be a composition, then these two arrows must be facing this side, right? And therefore now this, understand this function f, it is in this direction. So f of t is equal to x, therefore t is equal to f inverse of x. If I make this arrow like this, then it is going to be f inverse, but then I just cannot make it unless and until I am sure that it is invertible function, and that is where this first statement and third statement come in picture. Now f dash exists and is continuous, and f dash of t never becomes 0. Suppose the function is like this, then f dash exists, it is continuous and it is increasing, but then at this point it becomes 0 and then it becomes negative slope. F dash becomes negative. So if f dash of t is equal to 0 at some point, then we are not sure whether it is a strictly increasing or a strictly decreasing function. It can be increasing in some part and decreasing in some part. But as f dash of t is not equal to 0 for every t in I, now this is our I, a comma b is our I, and both the functions are defined from I to R. So instead of R, I am taking the codomain as e comma f here and c comma d here. So these two statements put together are telling us that f is strictly increasing or strictly decreasing. Therefore, it is 1 1 on 2. Therefore, there is a bijection, and therefore you can take inverse. Okay, that is the meaning of these two statements. Implication of these two statements, that they are saying that f, if you sketch f, it is either strictly increasing or strictly decreasing. You cannot afford to have a horizontal tangent anywhere. Then this is going to be in trouble. Okay, so third condition is making it 1 1 on 2, and therefore inverse is possible. So now if you take this inverse, then you can write this function y as g of f inverse of x. Okay, this chain is complete now. y is GOF inverse of x, and therefore dy by dx is equal to, सांगा काय करू, GOF inverse is a function. So GOF त्याला मी आता जर अजून वेगळ्या पद्धतीने लिहितो, g of f inverse of x. So y is equal to g of f inverse of x. Okay, and therefore dy by dx is equal to g dash of f inverse of x into f inverse dash of x. This is chain rule for composition. Chain rule for composition of function. बघा समजतंय का? Now g dash of f inverse of x. What is f inverse of x? T. So it is g dash of t into f inverse dash of x. We know that it is 1 upon, what happened? I have lost my, okay, something went wrong substantially. Okay, so let me finish. F inverse dash of x is 1 upon f dash of x. We know this, and that makes it dy by dt upon dx by dt. Just complete the writing at the moment. If required, we will discuss this tomorrow. I mean on Thursday. That is what is the proof. You are trying to create a composition of a function, and f dash exists and continuous, and f dash of t not equal to 0 makes it strictly increasing or strictly decreasing. Hence 1 1 on 2. Hence you can invert, and therefore this f dash of x goes in the denominator.